Welcome to this video from In 28 Minutes. In this video, we look at how the Java landscape has evolved in the last few years and where I see it going in the next few years. A number of times I am asked, where does the whole thing fit in? I'm learning Spring, I'm learning Spring Boot, I'm learning Spring Cloud, I'm learning a variety of frameworks. Where do all these fit in? What has happened in the past and what's going to happen in the future? And this video is an attempt to give you a kind of big picture on the whole thing. Now, before we start with this, important warning. Number one, this is my personal view, right? My experience might be different from a number of people who are out there. So this is solid, this is purely based on whatever experience I have developing a wide variety of Java applications. And the second important thing that you need to note is that I don't have any experience developing mobile applications. So we'll not be talking about things like Android or any of the mobile application frameworks in this specific video. Now, let's get started. During the last 2 decades, as I have been working with a number of applications, I saw the evolution of architectures from web applications to web services to microservices, and today we talk about the cloud. So this gradual shift in architectures has taken place over the last 2 decades. When I started developing applications, we were building mostly web applications, and the typical architecture of a web application is you would use a layered architecture. You have a web layer, you have a business layer, and a data layer. And this was typically when I started with developing web applications, I was starting with JSP and servlets. So I have actually built a few applications with pure JSP servlets and kind of a few client-specific frameworks. And for a couple of years when JSP servlets came in, there was no standard framework as such. Each of the enterprises had their own MVC frameworks, if I can call them that. And within a little while, we evolved to a very nice framework called Struts. So there was Struts, and then at a little while later, there was Struts 2. These were MVC frameworks. So Struts was a MVC framework, model view controller. So it helps you to actually divide your application into multiple layers and build nice web applications, right? So that's what Struts brings in. And after a couple of years, around the 2000 time frame, I think a little later, maybe the 2005 time frame is when the Spring framework came in. And the Spring framework web application component was called Spring MVC. And Spring MVC, first thing is Spring brought in a very, very important concept called dependency injection. It made developing loosely coupled applications very, very easy, and it helped us in writing great unit tests for our applications. So for me, the most important milestone as far as the Java landscape is concerned is the emergence of Spring framework and the emergence of dependency injection to develop our applications in a loosely coupled way. And from that time, I think it has helped us in developing really good applications with multiple layers, with great unit tests and things like that. The Spring MVC framework took the concept of dependency injection. Spring brings in the dependency injection concept, and Spring MVC helps us to develop loosely coupled web applications. And within a little while, Spring MVC became almost the standard way to develop web applications on the Java world. And slowly, we started switching towards SOA. After a little while, the service-oriented architecture picked up. So we started focusing on things like SOAP web services. So instead of building web applications, we were saying, why not offer services? Now, if you build web applications, what would happen is, let's say a Python application wants to use your business logic. Would that be possible? Nope. That's where the web services emerged. Web services provided a way to reuse services across different applications. So if application A exposed a web service, then I can consume it from application B. And the initial format was the SOAP. It was based on XML, Simple Object Access Protocol. Like with SOAP, you define a WSDL, a lot of procedure, a lot of ceremony around the whole thing, and we built a lot of web services using SOAP. And the architecture which was prevalent at that particular point in time was SOA, Service Oriented Architecture. And the popular options of developing SOAP web services, one was JAX-WS, which is the Java EE standard, so Java API for XML with web services, I think. I'm not absolutely sure. I would recommend you to check it out on Google. But JAX-WS was one of the options for you to develop SOAP web services. Spring also offered its own way. So Spring provided Spring web services. So Spring, this was a framework which was meant to help you to develop SOAP web services. And after that, after a little while, we saw that the industry was switching towards the REST API. SOAP involved a lot of ceremony, and we did not really want all that ceremony. We just wanted to create very, very simple web services, and that's where REST came in and said, okay, don't worry about anything. Just make good use of the HTTP. Just make good use of GET, POST, all the request methods which are present, and build your services around that. So this was a very, very simple way of building your web services, and slowly this approach of building RESTful API became very, very popular. The fact that at this point in time the full stack architectures came into picture as well really helped, because during this time frame, I think around the probably towards the end of the 2010 time frame I'm talking about in here, what happened was multiple devices started emerging. We just did not have one device. Earlier it was just like if I had to access an application, it was mostly on a computer or a laptop. But slowly mobiles emerged, slowly smartphones started coming up, and so there are multiple devices. And when you have multiple devices, you cannot have one UI that is rendered for all the devices. You need to have separate UI for each of these, and that's where full stack applications came into picture. So you'd build a REST API and you expose a front-end application. So the front-end application is typically a JavaScript application which runs in your browser. Today, as we speak right now, the popular frameworks to build the front-end applications are Angular, React, Vue, and all that stuff. And the REST API can be built in any language, right? So it can be Java, it can be Node.js, it can be Python. So in the Java side, the popular framework to build REST services was Spring MVC. So it's called Spring MVC, Spring Web, whatever you'd want to call it. So that's the popular framework to build REST API. Other than that, the other option you have is to use JAX-RS. So JAX-RS is again a Java EE specification, Java API for REST services, I think. And also like the implementation of JAX-RS, the most popular one is Jersey. So these are the two popular ways to build REST API in the Java world. And the front end, within the last few years, on the front end side, we have a number of popular frameworks emerging, right? So we have Angular. Actually, there was Angular JS first, and then it became Angular. And after that, we have React, and of late, we also have Vue.js, which is a popular way to build your front end. So that was how we started. We started with web applications. We moved into the world of web services. Among the web services, we started with SOAP first, and then we moved into the REST web services. And eventually, we saw that the applications really became big. So we started building a number of monolith applications. So around this 2012-2013 time frame, what we saw was we had applications which had 1 million lines of code. I worked with a couple of applications which had 2 million lines of code. So we saw that everything was becoming bulkier. I mean, if I want to do a release to production, it used to take 6 months. Or some of the projects I worked with had quarterly releases, and we really struggled to make that quarterly release, because there were so many things that were part of this single application, and it was impossible to take the application live. And that's where kind of, I think Agile started a little earlier, even before that, but Agile and also microservices around the 2015 timeframe, even a little before than that, that's where they all started. And we switched towards, instead of building a large monolith, we started building a number of small REST services which talk to each other. Now, a lot of people ask, what is the difference between a REST API and a microservice? Actually, not a lot. If you have a good REST API, and if it's independently deployable, and it has probably a very small boundary, like the small is a very, very relative term. So instead of building one large REST API for the entire landscape, probably if you are building a number of small REST APIs with individual boundaries, that's something you can call as a microservices architecture. So in the microservices architecture, it brought in a few problems of its own, right? So instead of having one monolith, you would have 20 services, or some places 2000 services, right? So now all these 20 services need to be able to talk to each other, need to be able to find each other. You need to be able to manage the configuration for each of these 20 services. And that's where a framework called Spring Cloud came into picture. So Spring Cloud is just a group of projects which makes it easy to build your microservices. Spring Cloud provides something called a service registry, where each of these services can register with the service registry and they can find the other service. So let's say this is microservice A and it wants to find microservice B. It can go and ask the service registry, hey, what is the address for service B? And what does the service registry do? It returns the address of, let's say 10 instances of service B are present, it would return the instances of all of them. So other than that, you'd want to have separate configuration. So each of these applications, microservices, might have multiple environments. So microservice A might have 5 environments, microservice B might have 4 environments, right? So typically you have dev environment, QA environment, stage environment, and production environments, right? So this is how our typical life cycle goes through. So you go from dev to QA to stage to production. I should get better at drawing these pictures. Hopefully with experience I would get better. And you'd see that in each of these environments, there might be multiple instances of each of these microservices, right? So in production, there might be a lot of load on microservice A. So you have a production instance A1, A2, A3, A4, and so on and so forth. So service registry helps service B find service A. So it says, okay, these are the 4 available instances, I can maybe distribute the call. So that's where you have a load balancing comes into picture. You'd want to store the configuration for each of these environments, dev environment separately, QA, stage, production environment separately. That's where there is a framework called Spring Cloud Config Server, which comes into picture. Each of these microservices have a number of common features that are present, right? So if there are common features across multiple layers in a web application or a REST API, we use aspect-oriented programming. So common features would be implemented typically using aspect-oriented programming in the single application space, right? When we go into multi-application space, microservices space, we have multiple applications, and how do we build the common features? Where do we build all of them? That's where an API gateway comes into picture. I would want to authenticate all these services. I would want to make sure that I have request throttling. There are a number of advanced features that you would want on your microservices. All these are typically implemented on your API gateway. So you can see that slowly from web application, we moved into web services, and in the microservices architecture, there are a huge number of complexities that are associated with managing your microservices. And that's where we started going into the cloud. What happened with the microservices architecture is all the infrastructure that is needed for the microservices is difficult to create, right? So you'd want to create a service registry, a load balancing, a Spring Cloud config server, and you'd want to be able to auto scale these microservices. You'd want to be able to provision resources on demand, right? So as microservices evolved, we saw that managing data centers was a very difficult thing, was very expensive. Let's say consider Amazon, for example, right? So Amazon during the Black Friday or during the Thanksgiving Day, it gets peak load. It gets a lot of requests, a lot of people who are shopping on Amazon. But during the rest of the year, maybe it's using only 10% of the resources or 25% of the resources. So most of the infrastructure in the enterprises remained unused. And that's where cloud came into picture, where it said, okay, don't worry about infrastructure, build very good microservices, and at the end of it, whenever you need some infrastructure, just provision on demand. So cloud enabled on demand provisioning of resources. So you can say, hey AWS, or hey Google Cloud, or hey Azure, give me this many like servers, and that's it. The next couple of minutes you will have all these servers available for you. So this reduces your costs, and this makes your architecture very dynamic, right? So that's where cloud made it very easy to reduce your costs and also build a dynamic architecture, because a lot of these clouds like AWS, the popular clouds today are AWS, Amazon Web Services, GCP, Google Cloud Platform, Azure. So that's the Microsoft Azure. So all these platforms provide the basic standard infrastructure by default. So if you want a service registry, or if you want to do load balancing, or if you want an API gateway, or if you want to manage your configuration, all these cloud providers provide a way to do that. And slowly, as different clouds came in, we wanted standardization. We did not really want to use a cloud specific feature. So if I use the service registry which is provided by AWS, what if I don't want to use AWS? I would want to move into something else. And that's where, like in parallel with the emergence of the cloud, I shouldn't say it's after it, it's basically along with the evolution of the cloud and the microservices, one more important tool which emerged was containerization. And the most popular way to containerize your applications was Docker. Microservices could be built in multiple languages, right? So you can have Java microservice, you can have a Python microservice or a Node.js microservice. So these microservices, when you have thousands of them, you'd want a standard way of deploying this. You don't want one way of deploying a Python application and another way of deploying a Java application. And that's where Docker came in, and it said, okay, don't worry, just put everything in a box and give me the box. So Docker helps you to build this box, which is just your application and your dependencies, and it made virtualization really easy. So instead of having different deployment procedures for different kinds of frameworks, languages and stuff, Docker enables one package. So once you build this package, you can build this package for a Python application, for a Java application, or you can actually build this package for a Node.js application. So any language of your choice, you can build a Docker container, and you can take this Docker container and put it anywhere in the cloud. So this is step one of standardization in the cloud, right? So this is basically standardization of how your application is packaged. And now, once the package is available, let's say this package or whatever is called the image, or the running version of an image is called a container. So once you have a container for different microservices available, you'd want to make sure that you'd want to be able to orchestrate them, right? So let's say I have containers available for microservice A, B, C, D, and E, and the load among them varies. So maybe the load on A is increasing drastically today, and I would want to bring in new instances. So 1, 2, 3, I would want 4, 5, 10 containers. This container 1 might go down. There's some problem with the application, it ran out of memory and it got killed, right? So what do we need to do? We need to bring another instance of the container up. So managing all this stuff becomes very big, very difficult. And that's where a concept called container orchestration comes into picture. So container orchestration is all about making sure that you have a specific number of containers that can handle the load on your application running, belonging to different microservices at all points in time. So the container orchestration one of the initial container orchestration tools that was in the cloud was AWS ECS. So it was called Elastic Container Service. This is a container orchestration tool, and it was amazing. I mean, the first, like when people saw what was possible through ECS, that was wonderful. And within like little bit of time, what happened was there was a tool called Borg, which was kind of doing this similar thing inside Google. And slowly, from the experiences of the Borg, out came an open source framework from Google called Kubernetes. And Kubernetes is today the #1 framework to do container orchestration in the cloud. So we use Kubernetes today to manage your containers and number of instances. You just need to tell Kubernetes, hey, I want this microservice, this many instances, this is the container for it. And Kubernetes would be able to manage everything for you. So Kubernetes has the concept of clusters, so where you actually create a Kubernetes cluster with a number of nodes. So if you have 10 nodes, let's say, and Kubernetes would manage all the microservices, how to how to deploy the microservices, how to monitor them. It takes care of all the typical features which are needed by your microservices. So Kubernetes provides its own service registry. Kubernetes does load balancing by default, and Kubernetes also offers a little bit of configuration. It might not be perfect, but it does offer a little bit of configuration possibilities as well. And the great thing about Kubernetes is it's cloud neutral. So today, GCP provides a GKE, Google Kubernetes Engine, Azure provides Azure Kubernetes Service, AWS provides Elastic Kubernetes Service. So all these cloud providers have a Kubernetes service. So if you're using Kubernetes and you are using just the cloud neutral stuff, you can move from one cloud to another cloud very, very easily. So that's kind of the big picture landscape, right? So we started with web application, JSP servlet, start Spring MVC. We moved into the web services world where we talked about JAX-WS, Spring WS, and then we moved into the REST world where we were actually building a lot of REST API JSON based using JAX-RS and Jersey. And around this time frame is when full stack applications came in. So there was a lot of evolution on the JavaScript side, ES6, React, actually Angular first, React next, and also Vue.js in the similar time frame. And slowly applications became big, and we went into the microservices world. Microservices had complex architectures, and it was difficult to manage them, and also the loads on the applications vary from time to time. That's where cloud came in and solved some of the problems that are related with microservices. And to be able to deploy your microservices to the cloud, we needed standardization, and that's where Docker and Kubernetes fitted the bill. So that's kind of the big picture of the whole thing. Let's now deep dive into the Java world and look at a few more frameworks around the Java landscape, right? So number one is the Java language itself. Java language itself has went through a lot of evolution, right? So if you look at Java, it's an object-oriented programming language. So that's what Java is. Java is object-oriented programming language. And if you look at the other languages which came in, like Scala, were functional programming languages. And functional programming language helps you to solve certain kind of problems in a much more efficient way than object-oriented programming. And that's where Java 8 brought in some of the functional programming constructs. So in Java 8, the functional programming constructs were first introduced into Java, and I think that was a very, very significant movement in the Java timeline. So there was I really had a fear at that particular point in time that Java language, the features it had were getting outdated. But with the introduction of functional programming and with the introduction of modularization in Java 9, I'm really happy with the progress which Java has made. Now, with modularization, Java became more mobile, more ready for the container world. And with functional programming, it provided all the real constructs that typical programmers would want from a good programming language, right? So from the language perspective, those are the two important features I would want to highlight. From the frameworks perspective, I think Spring revolutionized the whole thing through this concept called dependency injection. So dependency injection is the key thing which Spring brought in, and slowly actually Java EE or JEE as it was called at that particular point in time also brought in a container dependency injection standardization. So Spring also implements certain features of the CDI. I think it might actually implement entire thing which is present in the CDI, but Spring provides additional features on top of the container dependency injection. And with Spring Framework, one of the most important advantages that came in was that unit testing became easier. Okay, I'm bored of this blue pen. Let's go for some other color. Let's pick orange for now, right? So let's talk about the unit testing space. The most popular Java unit testing framework is obviously JUnit. You also have TestNG, which is a good unit testing framework. And to do mocking, typically we use Mockito. Spring also provides a framework called Spring Unit, which makes writing unit tests very, very easy. So that's kind of the landscape on the unit testing side of things. On the full stack type side of things, as far as Java is concerned, we developed the backend REST API for the full stack applications, and we already talked about the important frameworks, right? JAX RS is one of the important things, and also like Spring framework is one of the important things. One important framework which we missed while we were talking about microservices is the evolution of Spring Boot. So we actually forgot a very, very important framework, Spring Boot. Spring Boot, each of these microservices that we were talking about. So we moved from a world where we were building a lot of monolith applications to microservices. And with microservices, you wanted to be able to build them very quickly. You cannot spend a week or a couple of weeks configuring the frameworks, getting everything fine, getting auto-configured and all that stuff, right? So that's where Spring Boot came in and said, okay, you don't need to worry about it. I'll take care of all the auto-configuration. You tell me what are the frameworks which are present in the class path, and I would take care of auto-configuring them for you. So if you just add in a Hibernate jar, it would auto-configure a data source for you. So that's what Spring Boot came in, and Spring Boot made it very, very easy to develop the microservices framework. This was around the 2015 timeframe. So that's kind of like a very important thing that I missed. Oops, Spring Boot, how can I forget it, right? So now when we go to the full stack, that's where we were when we started talking about Spring Boot. Like the most important thing that we saw happening at this particular point in time is enterprises started expecting people, Java developers, to also learn full stack. So that's a very, very important career option today. So if you would want to actually learn ES6, that's the modern JavaScript. Old JavaScript was pretty difficult to maintain. Most of the time we were playing with DOM. So that's not good code. And ES6 brings in a lot of standardization into JavaScript. It helps you to organize your JavaScript code better. It brings in much better constructs into JavaScript as well, and it makes it easier to write good JavaScript code. And typically, you would also see TypeScript being used a lot today. So TypeScript further standardizes JavaScript and brings types into it. Types are nothing but classes. It makes it easy to have classes, interfaces, and things like that. Right, so that's the evolution which happened on the JavaScript side. And today, the popular frameworks that we already talked about on the full stack side are Angular, React, and Vue.js. I think React has a little bit of advantage on top of the other two. Right now, I would say the order is React, Angular, and Vue. But I've talked to a number of people who are absolute fans of Vue.js and absolute fans of React. So views might differ, but my personal preference is to go for React as of now. Now, before going to the emerging technologies, I would want to talk about the data layer. So data layer is one of the important things we build when we talk about Java applications. We started with JDBC first, so Java Database Connectivity. I hope that's the right expansion for it. Where we write a query, we get a result set, and then we what do we call it? Deserialize the result set. Is that the right terminology? Maybe. Nope. We deserialize the result set into a Java bean or a Java object, and we use that object in our application. That's where we started with. Slowly we evolved to frameworks like iBatis, which made it easy to do the deserialization. To bring the result set into your object was made easier by the iBatis framework. And from there on, we went into a framework called Hibernate. So instead of Hibernate said, why do you worry about queries? You tell me how your objects map your objects to your database. So you say this object is related to this database entity in this way. These are the fields. This is how they are named in the database. This is how they are in the bean. These are the relationships. This is a one-to-one relationship. This is a one-to-many relationship. You tell me how different things are mapped, and the Hibernate framework at this point in time would take care of generating the queries for you. So Java developers were really happy because they don't really want to write queries. Like, queries can become really complex and tough to maintain. So Java developers were very happy that there was a framework which helped mapping to the database. But obviously it comes with its own challenges. Let's say you would want to do something really complex. Hibernate might not be the right thing to use, and in that kind of scenario you might want to still go with Ibatis. But that's the thing which happened on the data layer side of things on the Java side. Once Hibernate emerged, Java also came up, Java EE also came up with a standard. That's what we call the Java Persistence API, JPA. And now Hibernate is actually an implementation of the JPA. So typically you would want to use JPA always, because that's kind of implementation neutral. So you use the interface, not the implementation. So you use JPA and not Hibernate. And you just add Hibernate as a runtime dependency, and everything would work magically. So that's the data layer. Now, let's look at a few other languages which have emerged during this time space. If you look at the languages which emerged during this time space, mostly one popular one is Python. I would say JavaScript is actually JavaScript was present even before Java. Actually, I'm not sure. I'm not sure if it's before Java. Probably a little after Java, I think. I'm not really sure about it. But JavaScript, Python definitely came before Java. That I'm sure of. Functional programming languages like Scala, and today we have Kotlin and Go. So these are the kind of important languages on the recommended side. So if you are trying to learn a new language as a Java developer, I think these are some of the languages you would want to learn. If you do JavaScript, you will be able to build front-end applications. And today, actually, if you are using Node, you can even build back-end API using JavaScript. Python is typically very popular in the big data, analytics, AI, machine learning, all these spaces. Python is very good. Scala is very good when it comes to big data, especially the Spark framework of Scala is very popular. Kotlin has done amazing things to make Java more readable. So it obviously, Scala and Kotlin compile down to bytecode, so you can actually run them on JVM. So if you want to build your Spring applications using Kotlin, that's possible. The most important part where Kotlin played a big role was in terms of developing mobile applications. So today, Kotlin is probably the preferred language. Whenever you're starting a new Android project, probably you would actually be starting using Kotlin. So for mobile developers, Kotlin has started playing a very important role. And Go is also very popular language to build some of the important tools. For example, Kubernetes is built using Go. Go comes from Google, obviously. So these are kind of the other languages. The emerging tech side, we already kind of touched upon them. AI, ML, big data, analytics, right? So big data, analytics. So these are some of the important things that are emerging on the emerging technology side. The most important thing for me is the cloud. So now, as a Java developer, what do I recommend you to learn? I think as a Java developer, the most important route that you need to take is to take the cloud route. Because I think whether you're going for artificial intelligence, whether you're going for machine learning, whether you're going to do big data analytics, all those applications would finally run in the cloud. So I would recommend you to get started with learning the cloud before you would venture into any of the other areas. And the great thing about the cloud is you are reusing all the experience that you have. So if you venture into an AI space, probably you would not take all your experience with you, right? So you might be starting almost like a fresher. But if you're going to the cloud world, all the experience that you have gained through developing web applications, web services, microservices, all that stuff you take along, and you might do wonderful things in the cloud. So there you go. I'm sure this was a long video, and I'm sure there are tons of things I missed. The idea behind this particular attempt is to, number one, familiarize myself with this new process of creating a video. So I thought, okay, this is a very, very interesting way of how you can actually teach, because it's very, very visual, and I feel like writing down stuff is what we are used to. This is how we are taught in college. So I thought, okay, let's do this. Let's try this new attempt. If you have any feedback on this attempt, if you are liking this attempt, do make sure that you like the video or you subscribe to the channel. Make sure that you tell YouTube that you really love this. And also make sure that you leave a comment if you have any feedback on how this attempt is, because we would want to actually create tons of videos in this format. I mean, this was a high-level overview video where we talked about web services at a high level, microservices at a high level, cloud at a high level. We want to actually create in-depth videos talking even deeper. So we just said for microservices, these are the options, right? We did not really talk about them in depth, but we have plans of creating more videos in the same format using this specific approach. So if you have any feedback, I would love to hear from you. The goal at In 28 Minutes is to help you to learn microservices, cloud, and full stack very, very well. We would want to provide solutions to make sure that you don't have any problems learning these three things. And I hope we are able to reach that goal. And have a great day. And I hope I'll see you in another In 28 Minutes video very, very soon. Good luck, and I'll see you again.